Hey, hello and welcome to the second part of the walkthrough for Windows PowerShell. And in this second part we will start where we finished in the first walkthrough, and we will discuss such thing as working with objects in your system administrator scripts. And we will begin with working with arrays of objects. For example, this could be the processes and the files of the file system. This could be registry entries or Active Directory entries. Anyway, first thing you need to do is to list them all. Then you need to filter them out, like to take what you really need instead of everything. And then you have to do something with them, either to output them to the console or put them to the database, whatever you want. So I'm running two processes. One is the notepad and the second will be the calculator. They will be here just to be in the list of processes. I'll minimize them and we'll run the PowerShell. So the first command that I'll give to list all the processes will be get process, and this is the list of all processes that are running in this machine. You can see the calculator, you can see the notepad there, and the PowerShell, of course. Usually what we need is either the process name or the ID, and right here we see 8 properties, and of course we have much more. We don't see it here because this is the default view, the default filtering, and usually we don't need the default. So what we need to get now is the list of all properties, not just handles and npm and ID and process name. We need to get them all. So to get them all, what you will need to do is to have the same command, get process, then type the pipeline. So when you are typing the pipeline, as you remember from the first part, you are staying in this context, so you still have that object, that array of objects, which is a result of the get process. And from that object you add the get member, and get member with the type of property. So you are effectively listing all the properties for the processes. So as you can see above, the type name is System Diagnostics Process, and here is a complete list of the properties for this System Diagnostics Process type, and it includes also things like container and session ID, site threads, and whatever else you may use in your scripts. And it's much better to get help on any of these properties before you are using them in your script. And also, as you can see, in the definition of each property there is a word get or get set, which means that either this field is read-only, which means you can get the value, or you can even set the value, which means you can change this property. If it's get, it's read-only. If it's get set, it's read and write. Some properties can even be set only, but not in this particular case. So in this particular case, what you can change, you can change the priority class, which means you can change the priority of this project and set it to low if you need to from your PowerShell script. But for example, you cannot change the ID of that process. That's quite obvious, and you can see that in the top of this list there is a name of the property ID, and it's only get. Also, it's of type system int32, which is the 32-bit integer. That could be useful information as well. So what we are doing now, we are getting the processes, and instead of type property, we get methods. So this is the list of methods. Methods, as you can see in my blog post, methods are the actions that you can do regarding this object. So for example, you can close this object, or you can even dispose it. Disposal means it will be destructed completely, and all resources will be free after you run the dispose. And of course, different objects have different methods. So here, for example, you have the kill method, which means that process will be killed. And obviously you shouldn't have such method for registry entry or for Active Directory object, because it would make no sense. But in this particular case, you have start, you have kill, and wait for exit, and so on. You can use these methods in your scripts. And what we are doing now, we are trying to get properties of one process. And in order to do that, first thing we'll do, we will list all processes with the command get process. But then after the pipeline, we will type where handle of this object, process name, and then, as you can see, minus EQ means equals. So the process name equals notepad. And here we go. This is our object. This is the process of the notepad. As you can see, the running application. So the process name property equals notepad, and also the result of this query gives us the handle to this object. So after the pipeline, after get process where process name equals notepad, if we will add the pipeline, we will be able to do something with that particular process. However, what we will do now, we will go further and format this list to include only the properties that we want to see. And notice, however, that what we see is just a representation of retrieved information, like your name is a representation of yourself, but well, it's not you, it's just a part of your identity. Your name is just a part of your identity. And the same as here, what you see here is just the top of the iceberg. So what we are doing here, we format the list, which means the list of all the data we get about this process, to include only the process name, ID, the main window title, and the path to the executable. And this is all we have. We have these 4 properties that we decided to get by using the format list. The notepad is the process name, the process ID, the title of the window, and the path. And in the list of properties that you've got before, you can see whether you can change these values or you can only read them. Now let's try to list the files, and as before we were working with the processes, now let's try to do the same with files. I'm trying to type the C Windows System 32 using the Tab key. Finally I got it. Using absolutely the same schema. First I get all the files with the dir command, and then where I'm using the where clause with as you can see, the GT means greater. I'm choosing all the files greater than 1 million bytes, which is almost a megabyte. So in this list there are only files which are greater than 1 megabyte, and they are not sorted at all. Well, actually they are sorted, but this sort is by default by name of the file. However, what to do if I want to sort them by the file size? Obviously I will do the same. I will add the pipeline, and I will add the sort by length. So in this case what I've got them sorted not by the name of the file but by the size. So the smaller files go first, the bigger ones are the last ones. And of course, as you can see, there are much more data about these files, and you can use it in sorting. For example, in what you see here, you can use the date, you can use the time, you can use attributes, and of course the length of the file and name of the file. But also there are a lot of properties which you don't see in this default view, and you can use them at all as well. Like for example, you can use the name of the owner and the quota assigned to that owner, and so on and so on. Whatever you want. And we will discuss later how you can get the ACL, the access control list of that files, in order to get the required data. So what we did now, we got the item property of one file object. So with get item property you get all the properties of that file or directory, and you've seen it in our first lab. And you can list all the properties which are related to that file system object. So mode, last write time, length, and the name is not everything you get about the folder, of course. And what we are going to discuss now, as our next topic, is such thing as the Backtick character. What we were using so far was the pipeline character, but there is another character which is the Backtick, and you will see how it looks here. it's the character left of your one key. And what it allows you to do, it allows you to, oh, I'm sorry, I typed enter where I shouldn't. It allows you to type your comment in a few lines, more than one line. So you're typing the comment, you're adding the backtick, and PowerShell is expecting you to continue your comment in the next line. And when you are run out of comments, you just type enter, and that's it. The only reason for this and the only purpose is the usability. So how you see your comment, if it's big enough, because sometimes you're not going to use PowerShell as in PS1 files, as in saved PowerShell scripts. Sometimes you want just to retrieve the information manually through the shell, like in good old Linux. In that case, using the Backtick character could make your command line more readable while lengthy enough. So we've got all the processes, the same as we did before. And then in the next line we add the pipeline, so which means we are working with the result of the get process. And the process name equals notepad. As you can see, the process name is case insensitive. We add the backtick character, so we proceed to the next line, and then we add the pipeline again, and we format this list to include only the process name, the ID, the main window title, and the path. This is it. Enter again, and you've seen it before. So as you can see, I typed exactly the same comments as before, but this time I typed them in 3 lines, which is easier to read, and this way I can see the whole comment, no matter how lengthy it is. Now let's try to do the same, but without the backtick character. You can do that in many lines, even without the backtick character, but the difference will be that you have to add the pipeline character. So after the pipeline you can press enter, and the PowerShell will expect you to continue your comment, because you know the pipeline cannot be the last one. So you type the pipeline, you type enter, and then continue your comment. It will be totally the same, just without the tick, the backtick character, but you will have to add the pipeline. You add the pipeline, press enter, and the same format list. As you can see, the format list is case insensitive as well. And we add the same properties as before. Main window title and path. This is it. Enter again. And we've got this same result. So take a look at this and think what is more preferable for you, to have the backtick character or to use the pipelines only. It's absolutely up to you. So as you can see, it's totally the same result, and inside there is no difference. Now we'll try to do a bit more useful things. And let's extend the previous command to list the content of the directory, and now let's include the ACL or access control list for that object. ACL, as you know, is the list which manages the access that other users and groups have to this object. So we will list files now with ACL for each one of them. We are in labs. As you can see, our root is labs, which is a directory, and you remember it from the first lab. And what we are doing, we get the child item, and we get it recursively, which means we will also go further down the directory tree. Next, we should get the ACL for returned objects, and then select each of these objects to load their properties. So after get ACL, we select that object, the single object, and we format the output to list only the path, the owner of that object, and the access list which was converted to string. The string representation of the access control list. And as you can imagine, we could use these to, for example, list only objects which do or do not have a particular user or group in their ACL, or have a particular owner. We could also get the list of files belonging to a particular owner and sort them by the file size. So the capabilities and the possibilities are endless. Any tools you can imagine are possible to do with just a few very simple commands. The next topic we're going to highlight is variables. And to do what we were discussing before, when you want to, for example, work with different users and display and find them, and for example, you want to find a user in Active Directory by mask and then display all the files which belong to that user on the file server, especially if you want to get the biggest files that belong to that user and lay on the file server. You need to introduce the variables, and in order to start working with variables, you need to learn something about them. Learn how to change numeric and string variables, determine if a string contains a specific character, replace value of the string, and so on. So for example, for the scripts which should migrate user data from one file server to another, you will need to find that user in Active Directory, get that object, find all files for that user in one file server, then change the name, the path of each of the files to include the second file server, and then to use the method of the file or directory to move that object. So you cannot do that without variables, really. So what is the variable? As you can see, I typed the sign and a, and this means that this is a variable named a, and I type it equals 10. So I introduce the variable. By default, all variables in PowerShell are variant, which means they can contain whatever, anything. So I can assign the value of 10 to that variable now, but later I can assign the string or the array to that same variable, and well, it will change its type. So now I type $bill A and plus equal. If you are C or C# developer, then you know that plus equal means that we add this value to that variable. So what we have now, we assign the 10 to variable a, but then we incremented that value by 2. So if we will type the $sign a, we will get 12, or at least we should. Yes, exactly, it's 12. This abstraction works the same way. You just have to type minus equals 5, and now it should be equal 7. Yeah, exactly. So it's only 7 now. And what will happen if we'll use quotes to designate that this is a string variable? And we'll try to do the same thing. So we introduce anonymous variable ABC and multiply it by 1, so it's ABC. But when we multiply it by 2, it's ABC. And when we multiply it by 3, you can see what happens. And if we multiply it by 30, I'm afraid I cannot pronounce it in time. And you can do that, of course, with all symbols you want, for any purpose you want. Like to have the line of asterisks or whatever. And let's see now how we could find out whether the string is like what we are looking for. We are using the like parameter to do that, just like in SQL, in SQL language. So we can introduce the variable, like this. We introduce the variable b. Let it be PowerShell. And now we can compare it using the like. And the mask that we are using is totally the same as the file mask you are using in a command prompt. So in this case it returned true, which means that the variable b, which equals PowerShell, is really like this mask, which is *w*, because asterisk means that there is any amount of symbols before the w, and the second asterisk means that there could be any amount of symbols after the w. So definitely the PowerShell complies, and so we get the boolean, which is true. The boolean could be either true or false, and in this case we've got false because we state in the mask that there could be any amount of symbols before the W but not after. So if our B variable would be like POW instead of PowerShell, it would be true, but now it's false. But now, when we say that it should end with L, definitely PowerShell ends with L. It's true again. However, like is not the only one thing to use when you are trying to compare strings. And as you can see, we use the question mark, which means that there could be only one symbol. The question mark means that you can have any single symbol in that place, while asterisk means that you can have any amount of symbols. And as you may notice, we used the where shell string, and by response of true, we get a hint that like is not case sensitive. So whether there is a capital letter or not, you still get the answer right. However, what to do when you need the case sensitive like? For that case, we have the so-called C like. C stands for case, as in case sensitive. So we type C like, and it's false now because the S is capital. Z should be false as well, of course. There is no Z. So it's exactly like the like, but case sensitive. And the not like means, well, when you want to get the result filtered, like for example, you want to get all files which do not belong to this particular user, then definitely it's easier to use the not like in the username. And the same, you can use the contains command. But contains is not about one string, as you can see here. Contains means that this array contains this string. So, for example, you are enumerating the Active Directory group, or you are enumerating the directory, the in-file system, and you want to check whether this Active Directory group contains the particular user, or whether this directory contains this particular file name. So then it's easier to use the contains. So when you're using it with a string, the only way you can get the true if you are using the exactly this string. We will look at contains a few seconds later, and now the last thing for a single string that you can use is match. And match just means that well, your string or your value should be exactly like the value you are trying to compare it with. So if you are trying to create an array of strings, like for example now our B will contain the PowerShell string, and if we try to run the contains PowerShell, of course it will be false. It will be true only if we will type the B contains PowerShell manual. It's not about the part of the string, it's about the exact string, which is part of the array. And of course, when you have a single value in your variable, like in this case, it contains only one value of PowerShell manual. Then, if you are running contains and compare it with PowerShell manual with exact value, then you will get true, of course. However, when we will create the array, and we are doing it by using comma, so the same variable, thanks to the fact that it's of variant type, now it contains two strings, and it contains PowerShell manual, and it contains PowerShell installation. It will be true again, but it doesn't contain PowerShell. So if you will run contains with manual or installation or PowerShell, you will get false. And now what is interesting, and you have to bear it in mind when you are using the like for single valued variable, like when it's PowerShell or PowerShell manual or whatever, for a single valued variable, it returns the boolean. But when you have the array, the result will be absolutely different. The result is the list. It's not boolean anymore. So you have to bear it in mind, and that's just another reason to debug your scripts before using them in production environments. Some commands produce different output in different conditions. Now let's try to build the string. I will clear up the screen, and we will create the variable h, which will be hello, and variable t, which will be equals there. And another variable str will be. Now take a look. In other programming languages, like in C#, for example, if we will type other variables in quotes, they would contain like $h, comma, space, $t. So they will not be translated into variables. But in PowerShell, when you're typing something like this, the str will be hello there. So even if you include this in quotas, your variable names will be translated into variable values. And that's another thing important to consider. And now we are trying to replace the hello with I from the str variable, and we've got the result which is hi there. But what is important here, we didn't change the variable str. Str is still hello there, but what we've got here was the sort of equation, was the expression which just replaced the hello from str variable with I. So we've got hi there, but it was not stored in any variable. We just made output to the screen. So if we retrieve the value of str, we will still have the hello there. It wasn't changed. So you can use these variables and use them just like you see. And if you don't use the sign of equality, you do not make the assignment. We would only change the variable if we would use the assignment, that is the equality mark. So if we would type something like in the top of the screen, like $H equals and then something, the value, only then we would change our variable. But you can use your variables wherever you like and even without assignments. When you just type the variable, you would print it to the screen or wherever you want. So this is like it. This is like it for this second lab. Thank you for your attention and have a good day.